In this video, we'll be learning about angles in four quadrants. Right, that's where four quadrants are from 0 to 360. They also turn into negative numbers and so on. So, just the preliminary talk, motivational talk here. Why would you need to learn these things that I'm teaching you? Because you may be inspired to become an engineer, a software engineer, or mechanical engineer, communications engineer, or some sort of scientist. So these waveforms are essential part of a lot of algorithms that run our day-to-day lives. You know that electricity sockets have electricity carry it for us with sines and cosine curves. All right. So all these alternating current uh, power is generated with three phases of the sine curve here. I'm showing you in this diagram. So it's important if you want to study any of these sciences, engineering, and furthermore in communications, all these triangular and square waves down here, they are generated using the preliminary, just the very basic sine and cosine curves that if you want to study further, you can look them up, how they generate square waves and triangular waves from just simple sine and cosine curves. All right. So with that, let's have a look at this first exercise. We are to generate a proper nice sine and cosine tan curve and compare it to what's happening with that unit circle up there. Uh, so what's happening when we calculating the sine of any angle is we are going to look for the opposite. Sine means opposite over adjacent. In this, we calling this graph here. First of all, let's make something clear. The x-axis, let's say this is the origin OO down here, right in the center of the circle. That's where we start turning, right? And we're calling this line here angle 0. To the right of the origin is the horizontal line here is called the angle 0. You might think, well, why don't you call the north angle 0? I don't know. Trigonometry uses the east side for angle 0, and then when I'll put an arrow there for you to understand, that's the positive terms for the angle. All right. If you count counterclockwise, this is counterclockwise. That's turning a positive towards positive angles. If you turn clockwise, this is negative angles. All right. So this is a negative 45 degrees. That's the meaning of sine negative 45. We are calculating the opposite to hypotenuse ratio for sine 45. If this angle is 45 here, this is because we turning clockwise. All right. So clockwise goes in negative direction, anti-clockwise or counterclockwise means positive direction, positive angle. All right, so make that association for yourself. So let's go back to the question we were asked to calculate sine of 0. What this? If I draw here, try to draw your right angle triangle here. The height of it, opposite side is 0, base and the adjacent is 1. By the way, we calling this radius of a circle. Why do we call it a unit circle? Because radius is 1. Just for simplifying everything, we're using a unit circle so that y here is divided by hypotenuse. Sorry, I said sine is opposite divided by hypotenuse, which is for 0 degrees. I cannot draw you a 0 degree angle because it lies on this red line here. So it's y is 0. That's why sine of 0 is 0. And cosine, you better get associations right. You're dividing the adjacent side of this triangle, which is the x value, by 1. All right. So that's the main thing to remember for the rest of these quadrants. All right, so let me get rid of this and let's get started doing this. tan is opposite over adjacent, so y over x. So there is 0 and 1. So cos of 0 degrees is 1 because the length of x is 1, 1 divided by 1 is 1. 45 degrees. We're looking at this triangle here. I'm plotting the lines there for you. Opposite is divided by hypotenuse, so that really why the if you get use Pythagoras and calculate for 45 degree, these two lines must be the same length. So we'll have 0.70 for sine and 0.70 for cos. And finally, when you divide blue line by blue line, that's this blue number divided by this red number, you get a 1. So tan of 45 is a 1. Now, this is a triangle. I know it doesn't look like a triangle, but 90 degree. It's just, if you think about x value for this triangle, means that the x is 0. So y will be 1 and the x value is 0. So sine of 90 is what is sine is 1 because you divide them 1 by 1. The height of the triangle is 1. The width of it is doesn't matter. The hypotenuse is 1 as well. So then cos of that angle is 0, and tan of 90 degree doesn't exist because we cannot divide by 0. We divide in y by x, and so on. So now, if you have a angle that is obtuse, that is more than 90 degree, you actually draw your angle in the, this is called the first quadrant, second quadrant, third quadrant, and the fourth. You draw your triangle in the second quadrant, okay? So first is for angles between 0 and 90. If you have an angle of more than 90 degree, you draw yourself a right angle triangle. This is still a right angle triangle here, but its x value is what? It's the point is, if that's the origin, x value is negative here. Alright, so that affects a few things. I'll put the x equals to -1 there for you, so you recognize if x here is the length -1, not here. This is negative 0.707. So I've put these numbers there for you, measurements on the graph from the graph there for you. So the when you have well, you're dividing the y value by 1, so it wouldn't change, and its tan is negative because negative 1. Alright, so what are we looking at? This is angle 135 because we added 45 to 90. Okay, so we just did that, and 135. I say 5 on the right 4. I don't know. Okay, so degrees. That was second quadrant. And now looking at 180 degrees. Sine of 180 degree is 0 and cosine is -1. So because why is the sine 0? Because there is no height on that triangle. Okay, compare we join our notice of triangles always are related to the x-axis, not the y-axis. Okay, so make another connection there for yourself. 180 plus 225 degrees here, and its sign is negative. Then you can write this as a fractional. I'll show you what's the exact value the next exercise. For now, just for here, and sine is 1, cosine is 0, and so on. So notice we are always comparing our angle, or rather drawing a triangle, and it's corresponding to the x-axis, not the y-axis. This angle, if your angle is more than 180 and less than 270, you can draw it in the third quadrant. And if your angle is more than 270 and between 360, you're going to draw it like so. It's going to turn into acute angle here. All of these angles are acute, and we're going to look at the connection between acute angles and reflex angles in a minute. So just let's finish this part of the graph off. So for negative angles, I already told you that that is the same as going, that means going clockwise from zero on this triangle. So negative 45 has the same value as like if I'm taking sine of negative 45, it's the same as sine of 360 plus minus 45, which is 320, 25, no, 15, sorry, 315. So that's to draw the negative part of the graph. I'm just showing you that this is 360, all the values are repeated. We've made the full period there. So I'm showing you that I'm putting the negative angles here for you. Going back from that zero there, there's no space for me to write to the left, so I put another table here for you. All these values repeat themselves. So once you start plotting them, you get these two nice curves. I've used Despo's graphic calculator here for you. So you understand that this is a sine and it reaches its maximum at 90 and its minimum at 270, and you can imagine the rest. So here is negative 90 and here is negative 270. Sine reaches its minimum at 180 degrees and maximum at 360 again. So you notice that sine, alright, uh, the sine is, you need to make this association, is associated with the y, the vertical length of the triangle, or the opposite side of the triangle. The y value, cos is associated with negative. uh, when y turns negative, sine is negative. So why is it that this sine of 270 is a minus 1? Because y value here is negative, alright? And you're dividing that negative 1 by negative 1, or by a positive 1. The hypotenuse is always positive, so negative divided by positive remains positive. Why is it that the cos is negative 1 at 180? Because we turned all the way here and we said the cos of it's impossible to see a triangle here because it has two sides lying on top of each other. The hypotenuse is the same length as the adjacent. That's why the adjacent side is negative 1 and the hypotenuse is positive, so that's why the cosine of 180 is negative 1, and so on. So you are to understand these. This is the identity. If you remember, I explained this to you with a CT rule in chapter 9. If you don't remember, go and look at that up. And sine of, if you add 180 to any angle, it will be the reflection of that angle in the y-axis. Alright, so you need to remember this rule here. And also, if you say take the complement of 360, take the 360 and take away that angle, it will be again it's reflection of that value in the y-axis, or its negative value. All right, so 100, the tan repeats itself every 180 degrees. That's that identity there. So that's why tan of theta is the same as tan of theta plus 180. Now 360, uh, if you this is what is looking, what we are looking for. So if you have tan of a negative angle, let's say tan of minus 45, that's the same as, you could say that's tan of, to turn it into a positive angle, you could say that's the same as tan of 360 minus 45, which is 325, sorry, 315. And also that's the same as tan of what? That's negative tan of 45. Alright, so with tan, you can take the minus sign and put it outside. If you want to turn this angle into a positive angle, you do this, and the same goes with sine. If I briefly explain to you with the graphs, what with the graph transformation, sine of a negative angle is the same as negative of the sine of that angle. So remember that. That's why that's this rule coming from here. So this is just saying adding 360 really doesn't change the sign. So that's the same as saying sine of a negative angle is the same as negative sine of that angle there. If you don't remember, go look at the trigonometric graphs where I showed you this and you remember. So then, alright, so remember this rule. If you have one angle here that you calculate, there are multiple answers. There are multiple answers. If your first answer is 30 degree, your second angle is going to be 150 because that's 180 minus. I know this angle is acute. This angle is 180. I'm saying sine of. I'm not saying sine of 30 is equals to sine of 150. All right. So if your angle is negative, right? So let me wipe that off. So if the angle is negative, a negative angle, it has another corresponding value. All right. When you're evaluating sine, remember this. So, for example, we are just in the very last video, last slide I showed you. Sine of negative 30 is the same as negative sine of 30, and that is again sine of 180 minus a minus 30. Alright, so what's 180 minus 30? That's 180 plus 30, which makes 210. So I'm saying these have the same value. If you evaluate this, this is the same as sine of negative 30. Okay, you can check it for yourself, because they have the same y value here. I've tried to color code this for you with dots there. That height is the same as that height there. Alright, this negative y is the same as this negative y. That's why you do 180 minus minus makes it a plus. Really, you're adding 180 is here, you're adding the absolute value of that theta there to 180. Alright. So the sine of those is the same. Cosine of these angles are the same because they share the same adjacent side. Alright. So what I'm saying is that if you remember the graph, we did say that cos of negative theta is the same as cos of theta, and that was graphically because it's reflected in the y-axis. Now here, yes, the graph is reflected, is symmetric around y-axis. Remember, its maximum was at 1 when x was 0 there. Alright, so that's why it's happening here. So it is minus theta here, and for any of these two angles, isn't it? So that's one identity you need to remember. The other identity you need to remember from cos theta is that this angle cos theta is the same as cos of 360 minus theta. Okay, so take its complement from 360 because the cosine curve reaches maximum at 360. However much you go forward here, you can go back from 360. Right, so remember this identity is very, very important. So yeah, I'll write it again. So, and then tan of these two triangles is same because negative and negative divided together give you same ratio as the positive and positive divide by together, and tan of those two triangles is the same because they're diametrically opposite to each other. So let me make make this a little clearer. perhaps. So write this again for yourself. Cos of theta is equals to u 360 minus theta. All right. This so I'm saying cos of what am I saying? I'm saying cos of 30 is the same as cos of 330. Why? Because 360 minus 30 is 330. All right. If you give me cos of 50, I'll tell you there is another. So when you have to find multiple angles, you say if I find my first angle to be 50 and my range is between 0 to 360, I actually go and subtract. So I say that's the same as cos of 360 minus 50, and that angle is therefore 310. So that's the other value. And then if your range was even more, if it was 720, you would just go and add 360 each of these values. Alright, so these are called the principal values that we are finding. And principal values, you always can add 360 and subtract 360 from them to find the other values as well as those. Alright, so with tan of theta is the same as tan of 180 plus theta, tan of theta plus 180, or tan of theta minus 130, 180. So if you solve, you took tan inverse of some ratio, let's say you took tan inverse of, I don't know, 1 and you got 45 degrees, then the other answer, the other principal value is adding 180 to this and saying actually tan of 225 is the same as that. So when you solve equations, you need to use these identities to figure out. And if they said give me the answer between minus 180 and positive 80, you subtract 180 from that. You say 45 minus 180 would give us 100 and negative 150, right? No, that would be 35, negative 135. All right, so these angles are equivalent angles when we're using tan. It depends on the problem, okay? If you're using tan, you're going to use these identities. If you're using cos, remember this identity. And if you're using sine, remember the identity. Sine of theta equals to sine of 180 minus theta. Alright, with those, let's solve some problems. So we've been told to write sine of 130 as sine of an acute angle. So that means that take sine take 180, subtract it from, take its complement from 180. 180 minus 30, 130 is 50. Alright, so that's what it means. 130 somewhere there, and acute angles are less than 90 degrees. That's what we want. We wanted to get it to get the acute angle, which is 50. I'll put it in this box here. But if it's not clear, these two signs are the same. Alright? Remember this rule. We just discussed that. And now they told us write this negative angle as a positive angle. Alright? What do we do? Negative angle is somewhere here. And it's better for me to look at the unit circle here. I say sine here, if this angle is negative, so its sine is here, is alternate, its equivalent angle lies in this quadrant. Remember, I said these two have the same y value. So I'm going to take minus 30, say plus 180 minus a minus 30. That makes a plus, so that's 210, right? That's how I figure out the answer because I know sine of theta is the same as sine of 180 minus theta. So even if your angle is negative, you still use the same formula. It works out. So 210 is the answer we're looking for. And if you had to go and find the other answer between 360, that's not the only answer. You also say, well, that theta, it was negative 30. I will just add 360 to it, and this answer is 330. That's how we get there. Or you could go backwards and say 360 plus theta. It's the same thing, isn't it? Because our theta is a minus 30. It works out to be the 330. Okay, so this is exactly the equivalent diagram I've drawn for you up there. I'll put it down here below again. So because of those ratios, if you don't remember them, pause the video and write them down for yourself. Okay. So in this next question, we've been told to write this cos of negative 120 as an acute angle, cos of an acute angle. So you think to yourself, 120 negative 120 is like turning this from zero there, turning to this angle here. How do I deal with that? Do you remember this identity? Cos of theta is the same as cos of 360 minus theta. Now, if I apply that here, cos of minus 120, I'm setting theta to be negative 120. So substituting that here means that that's the same as cos of what's 360 minus a minus? It makes it a plus. Mm, So, okay, that goes beyond the range. That's not the acute angle, but we know that. Alright, so we're gonna basically what we're saying is that the adjacent side of this triangle, what is it? It has to have a negative sign in front of it. It will be the same as cos of positive 180. Now cos of positive 120, sorry, so this is the same as cos of these two are the same, and this cos of 120 is the minus of is the negative of what? This angle, what's the difference between 180 and alright, so this is a complicated example, so I hope if you want to take a break, pause the video, have a break, and then let's come back and have a look at this question. It's given us a negative angle, and the question is asking us to turn it into the first quadrant. So that's why I put a arrow there for you. This arc here is saying that I'm actually going to say this triangle here that I have down here, I'm going to find this equivalent cos value. Cos is this x value, right? I'm concerned with this x value. But obviously, I cannot, x is negative in this quadrant, in the third quadrant. So I'm going to go and find this equivalent positive value and then just put a minus sign in front of it. That's the only way to deal with this problem. So we actually going to add 180 to this angle here. It's a negative angle, so I'll put a minus sign in front of theta, but in general the rule is that your theta, if you add 180 to cos inside the cos function to the theta, then you have to put a minus sign in front of it because you see these blue triangles here. This is what we're calculating. We're calculating the its is equivalent triangle in this first quadrant here, because they told us acute angle. Acute angle has to be in this first quadrant. Okay, we have to somehow find its equivalent of this angle 120 degree, negative 120 degrees in the first quadrant. That's why we're going to say what is negative 120 plus 180. It's going to be positive 60, right? So we're going to say we are taking cos of 60 degree, but we're going to multiply that by minus 1. We have no choice because we know that we have to, what we found here is in this first quadrant, but our actual angle is in the third quadrant, okay? So we have to multiply, put a minus sign outside of the function when we have calculated the acute angle. And there is another proof here. So it's just saying that this y value, all right, the function is going to be negative, but its equivalent positive is its reflection is up here, but obviously the y that we want is down here. So we're going to take cos of, go ahead and calculate cos of 60 here, find what is this value, and then times it by negative sign, negative 1. So that is what they told to be. They told us to be negative 120 degrees, right? So maybe you want to put this two in your toolbox, write these two down. That's what you do if you've been turned to turn an angle into an acute angle, alright? So in this next question, we've been given tan of 190 degree and tan of negative 50 as tan, write them as tan of positive angles. So let's deal with one of them at a time. There are two questions in one at this moment. So tan of 190. We said that the tan graph repeats itself every 180 degrees. So we can just take away 180 from 190 and that would be 10 degrees. So that's equivalent to 10 degrees. Like if it's 190, when you turn positive, means that go here. This angle is 10 more than 180. You agree with that? So, and it's, if you think about the graph, we said that this line here is equivalent is in that first quadrant. The third quadrant is equivalent to the first quadrant, and so on. So that's the same as the tan of 10 degrees. You can look at the graph above if you wish. And then tan of minus 50, we said, if you remember, it's because tan is an odd function, tan of a negative angle is the same as negative of tan of the positive angle there. So you could take the minus sign out from inside the bracket, put it outside in front of tan. Alright, so that's like, but that doesn't, yeah, that makes it minus tan of 50, and that works. Okay, so that was the, if I rub off my graph here, that means that what we said with this second one is that we, with the first one we turned the third quadrant into the first quadrant, and finally from the from the fourth quadrant we turned it into, we said if I take 180 and subtract it, it won't give me the correct value, so I need to find its equivalent by putting minus sign outside of the time. So okay, so that's what we did. These are the other equivalent angle we went asked to find acute angle. These are not acute, so they're not working out for us. So it's tan of 130 is the same as tan of 360, but that's not relevant. Alright, so good luck practicing these questions. I'll see you in the next video.